We're talking about 14.8, the B and C level problems. So we're going to go over a couple of these. For 15, they give you this figure. I'll show you what they give you. They give you this, and they give you this. All right, so this one that I just drew. This is my point of rotation. And what they want you to do is they want you to draw, copy the figure and show a complete figure so that it has all the specified symmetries. So they want you to have 180 degree symmetry. So look, here it is with 180. You can kind of see if I take my pencil here or my pen and I kind of, go 180 degrees. There's my angle of rotation there. Okay, can you see it? All right, and then here is what a 60 degree rotation. I start with my starting point, my little L guy, and I rotate him 60 degrees. Then this is what 120 looks like, right? See that? Okay, so what I need to do is combine all three of these rotations and into one drawing. So, here's this one. Okay, here's the 60 degree here, but I got to add the other half because it's got to have 180 with this one too. And then here's the 120 right there. Okay, but I got to add the other half. So this is a figure that has 60 degree rotational symmetry, 120 degree rotational symmetry, and 180 degree rotational symmetry. It also has more. It has 240. I could do two 120s. This has an infinite number of symmetries, but it just wanted 180, 60, and 120 to be shown. So there it is. All right. The next problem here, 21. We're supposed to draw the figure if there's one that meets the conditions, otherwise, right, not possible. So we want to know can we draw a trapezoid with no symmetry. Just any old regular garden variety trapezoid will have no symmetry as long as it's not isosceles. All right, so you can see there's no way I can get any symmetry out of that. If I want one line of symmetry, I can draw an isosceles trapezoid. There's my line of symmetry. You can see if you fold this piece over onto this, it'll map this chunk to this chunk. Okay, very mathematical language I'm using here. And part C on 21 says if you could have a symmetry point. Not possible to have a symmetry point. Because, you could have a symmetry point in a square, but not a trapezoid, because this length is longer than this point. So if I was trying to find a symmetry point somewhere there in the middle of an isosceles trapezoid, I couldn't do it, I just couldn't do it. All right, so that's 21. All righty, and then 23, this is the last one here for this. 23 says it wants you to draw an octagon with 8 rotational symmetries. So, here, you can kind of think of this as like a doorknob, and each symmetry here I can rotate. Basically, this is an apothem, right? This can go from here to here, rotate the middle of one side to the middle of one side. So I can do it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, and then 8 times again. So you'll have no idea how long it took me to draw that beautiful octagon. All right, that's part A. Part B says we want to have just 4 rotational symmetries. Now look, this problem gave me problems because I wasn't thinking outside the box. I was thinking inside the box. This is a regular octagon. It is convex. It's not concave. This one is concave. Remember the definition of concave? That, these points or these lines, if extended, go through the middle of your polygon. So this one is a concave polygon. I was thinking convex, but here is one with 4 rotational symmetries. All right, you can see that, this point, when I rotate it 90 degrees in the clockwise direction, this point goes to here. Watch this. See, there it goes. This point, there's 1, there's 2, there's 3, and back to the top gives me 4 rotational symmetries. So there's that one. All right. Part C says you want an octagon with only point symmetry. Now, point symmetry is basically the idea of a half turn, okay? The definition in the book for point symmetry says that for each figure there is a symmetry point O say, such that a half turn about O maps the figure onto itself. So when you're looking at point symmetry, you're looking for half turns. So, here is an octagon, and barely, I mean, it is 8-sided. I mean, somehow, there's just, this looks like two rectangles stuck together, but let's pretend there's a little space in between these. So anyways, this octagon here, if I somehow, I don't know, I need a little bit of a better picture, but you got the idea here. Yeah, so this has point symmetry. A regular octagon has point symmetry, but they ask for a picture with only point symmetry. Okay, so this is barely an octagon, but you get the idea. All right, I have to. I got a little space go through there somehow. Maybe if I just kind of, drew this like at an angle. You get the idea. Alrighty, so that's 23. I'm done with this one now.